The problem we're going to work now is a little more complex. We have block A on an incline connected to block B via some pulley, where again block A will accelerate up, block B will accelerate down, and let's assume that we are asked what is the acceleration, sort of the typical question that we're asked. We will assume that there is friction between the block A and the incline. We're given that as mu k, and we are told the angle theta. To test yourself, if you'd like to, go ahead and attempt to draw the free body diagrams for this scenario. Pause the video and see if your free body diagrams match the free body diagrams that I'm about to draw now. Let's draw box A first. Excuse me for bumping the camera. Let's draw box A first. I like to remind myself what the direction of the angle of incline is with a little dotted line. Then I'll draw box A on that dotted line. Box A has a weight that is straight down. With respect to the incline, this is angle theta now. We know that there is a tension going up the incline, so we'd have the force of tension. Sorry, this was F of G of block A down there. We have tension up the incline, the weight down the incline. We know that there is a small friction force that's working against the motion, so we have a kinetic friction force, and we have a normal force, F of N. I know that I am going to eventually break my weight here into an x component, so I would have F, G, X, and F, G, Y. So I can keep that in mind using that angle theta. Excuse me. The y component, of course, is that. The x component is that. I don't know what I was thinking. It's late at night. Y component down like this, and the x component like this for that weight. We will break this weight into our components because we will be declaring up the incline to be the positive x-axis. As we discussed in class, we often choose the direction of the acceleration, if we can, to be the direction of our positive x-coordinate. So now let's look at this free body diagram, this force diagram, and get our equations for Newton's second law. Again, it would probably be great if you took an opportunity to pause the video, attempt to write those equations yourself, and see if they agree with the equations I'm going to write now. So the sum of our forces in the x direction would give us, for this case, the tension force was in the positive x direction, and then I have two forces in the negative x direction. I have the kinetic friction force, and I have the x component of my gravitational force. X component of my gravitational force. And that's got to equal mass times acceleration in the x direction. Then in very general terms, for my y direction, F of y, I'm going to have an upward normal force, Fn. And then down, I don't have the weight, but I have the y component of the weight. And that's going to equal the mass times the acceleration in the y direction, which would be 0. We should specify this as mass A. So if we wish to build this equation up just a bit, we'd have the tension force minus mu times the normal force minus the x component, which would be mg times the the sine of theta, and that's got to equal mass of A times A of x. This should be mass of A. The reason we're taking sine of theta is because that x component here is the opposite of this angle in our force diagram. Now this normal force, we can use our y equation to get the normal force, but this is equal, the normal force is going to equal the y component of the weight, so that's going to be mg cosine of theta. So our final expression here is going to be the tension force, not our final expression, but the one that we're going to use going forward, where we'll substitute in this for the normal force, mag times cosine of theta minus mag times sine of theta, and that's got to equal ma times my acceleration in the x direction. So we've got this as sort of our complete useful equation from block A. This is all for block A. Let's draw a force diagram for block B. So our force diagram for block B, let's get back to black. Block B is just going to be, our weight down. So we've got FG, if we want to call it FGB, down, and then our tension force up. So the positive x-axis will take to be down. So that would give us the equation, the sum of forces in the x direction. We'll say Fg of block B is positive minus that tension force will give us the mass of block B times the acceleration in the x direction, or that our tension force is equal to, I'm skipping ahead because I kind of know that this is going to be the useful thing that I'm going to substitute back in, mb times g multiplied by mb times ax. Then what I'm going to do is I'm going to take this equation and substitute it back into this expression for f of t, and I get the following. I'm going to go all the way on a brand new piece of paper because I know I'm going to need the room. So let's first copy down that expression that we had for block A. F of t minus mu times the mass of block A times g times cosine of theta minus the mass of block A times g times sine of theta. It's going to equal the mass of block A times my acceleration. I'm going to drop this acceleration in the x direction because I know they're the same accelerations by my choices. Then I'm going to substitute in what I had from the previous page for f of t. So that was that the mass of block B times the gravitational acceleration minus the mass of block B times the acceleration in the x direction. That's all for f of t, minus mu times the mass of block A times g times cosine theta minus mass of block A times g times sine of theta is going to equal the mass of block A times the acceleration. I'm solving for A, so we'll move this to the other side, and I'm going to pull these things apart and kind of simplify it a little bit. The mass of block B times g minus the mass of block A times g, and then in parentheses I'd have mu cosine of theta plus sine of theta. It's going to equal A times the mass of block A plus the mass of block B. So I'm just a step away from writing my acceleration as one statement. It would be mb, the mass of block B times g minus the mass of block A times g multiplied by the quantity mu cosine of theta plus sine of theta all over this whole thing over my total mass of block A plus mass of block B. That would be my expression for the acceleration with all of our algebra worked out.